Hello everyone, welcome back to another video. This is a two-part series. This is part 1, and in this video I'm going to walk through installing Ubuntu Server 22.04 LTS in VirtualBox, updating it and connecting it remotely over SSH. So let's start by grabbing the installer image. To begin, open up your browser and navigate to releases.ubuntu.com. Scroll down until you see a directory of all the versions of Ubuntu. I'm looking for Ubuntu Server 22.04 and I'll click on it. You'll notice I'm specifically choosing the LTS release rather than a short-term one. LTS stands for long-term support. Canonical backs these releases with 5 years of security and maintenance updates, which is exactly what you want on a server that has to stay reliable and patched for years, not just a few months. That's why LTS releases are the standard choice in almost every production and enterprise environment. I'm going to continue scrolling down until I see server install image, and I'm going to download the 64-bit PC server install. As you can see in the top right hand corner, it is downloading. As you can see in the top right hand corner, it is downloading. While that downloads, let me confirm the hypervisor I'm using. So I'm going to open up VirtualBox. I'll go to Help and About VirtualBox. I'm using version 7.2.10, so I'm good to go. I'm going to click on New to begin configuring this virtual machine. I'll be naming this virtual machine Ubuntu-server-22.04. I'm going to add the ISO image I just downloaded. VirtualBox has automatically detected the type as Linux and the version as Ubuntu 64-bit. On the hardware screen, I'm setting the memory to 2 GB and allocating 2 CPU cores. For the storage, I'm leaving it as 25 GB. What you want to do now is just open up the settings for your virtual machine and head down to Network, and I'm switching it to Bridged Adapter. With Bridged Adapter, the virtual machine connects directly to my physical network, just like another device on my Wi-Fi or Ethernet, and it will get its own IP address from my router. That makes it simple to reach directly from my host machine later for SSH. I'm clicking on Start to power on my virtual machine and start the installation. I'll begin by clicking on Enter. I'll let it install its necessary repositories. The first screen is language. I'll select English and continue. Next is keyboard layout. This is correct for my keyboard, so I'll continue. Here I'm going to choose the standard Ubuntu server. On the network screen, you can see the installer has already picked up an IP address automatically through DHCP. That's the address. So I'm going to continue. I'm not setting a proxy, so I'll continue. And I'm going to go ahead and bypass this by clicking on Done. I'm continuing. For the storage configuration, I'm choosing to use the entire disk since the virtual machine's virtual disk is dedicated entirely to this install. I'm keeping setup this disk as an LVM group checked. LVM stands for Logical Volume Manager, and it lets me resize storage later without having to repartition the disk from scratch. That flexibility is why it's worth keeping on, even for a lab environment. Once I'm finished, I'll click on Done. Here's the partition summary the installer has generated. I'll confirm this and accept the warning link that will erase the disk. That's expected since this is a brand new virtual disk with nothing on it yet. Now I'm going to quickly set up my administrator account. I'll enter my name, a name for the server, and a username. I'm also going to be setting a strong password. I'll click on continue for skip for now, since I'm not installing the Pro version. This next step is critical. This is where I enable SSH access. I'm checking the box for install OpenSSH server. Without this checked, I won't be able to connect to the server remotely later on. So this is one of the most important steps in the whole install. On the next screen, I'm offered some optional featured snaps. I don't need any of these for this assignment, so I'll leave them all unchecked and continue. Now the actual installation is running. You can see the progress log scrolling as the packages get installed. The installation has finished, so I'll select reboot now. While it boots back up, let me quickly show that the VirtualBox has unmounted the installer ISO. I'll open the virtual machine's settings and I'll go to storage, and you can see the empty optical disk. That confirms it's unmounted, so the virtual machine will boot from the hard disk instead of looping back into the installer. The system has booted to a login prompt. I'll log in with the username and password I created earlier. Now let's update the system. I'm running sudo apt update and sudo apt upgrade with the -y flag. I'll quickly enter my password to go ahead with the install. While this runs, let me explain what's actually happening here. Since these are two different commands chained together, apt update doesn't install anything. It refreshes the local index of what packages and versions are available from the configured repositories. apt upgrade is the command that actually does the installing. It looks at the refreshed index and installs the newer version of any packages already on the system. The -y flag just auto confirms the upgrade prompts, so it can run without me manually typing yes for every package. Once the system is fully updated, I'll set up the remote connection. I'll run IP space A to get the server's IP address. Here's the output. I'll open my notepad to save the IP address. I'm saving it to my notepad since I'll need it for my host machine in a moment. The IP address is 192.168.100.32. Now I'm switching over to my host computer and I'm opening a terminal. Since I set this virtual machine up with a bridged adapter, I can connect straight to the IP address I just found. I'll type SSH, my username, and the server's IP address. It's asking whether I want to continue connecting since this is the first time my host has seen this server's key fingerprint. I'll type yes and enter, and I'll enter the password. And there it is. You can see my terminal prompt has changed to show the server's hostname and my username. That confirms I'm now connected to the Ubuntu server remotely over SSH, which completes part 1 of this assignment. Now let's move on to part 2, where I'll install a web server on top of this. Picking up right where I left off in part 1, my Ubuntu server is installed and I'm connected to it over SSH. Before installing anything new, let's refresh the package index. I'll run sudo apt update. That refreshes the local list of available packages and versions. so the system knows about the current version of Apache before I install it. Now let's go ahead and install Apache. I'll run sudo apt install Apache 2 with the -y flag. Let me make sure I put apt here so it can run. As I've explained already, the -y flag automatically answers yes to any installation prompts, so the install runs straight through without me having to manually confirm anything. Let's confirm that Apache actually started. I'll run sudo system control status Apache 2. And right here, you can see that the status is active and running. So that confirms that Apache service is up and listening for web traffic. I'll press Q to exit. Before I touch the firewall, let's check its current state. I'll run sudo ufw status. It shows inactive. UFW comes disabled by default on a fresh Ubuntu install. That's intentional so a brand new server doesn't start blocking traffic, including my own SSH access before I've had a chance to configure it properly. Before I enable anything, I need to allow SSH through the firewall first. I'll run sudo ufw allow OpenSSH. I'll also allow Apache support AT web traffic gets through. I'll do sudo ufw allow AT/TCP. This ordering really matters, so let me explain why. I'm connected to the server right now over SSH. If I turn the firewall on with its default deny incoming policy before allowing SSH, that same firewall would immediately cut off the connection I'm using right now. I'd be completely locked out of the server with no way back in except physically through the VirtualBox console. So the rule is always allow SSH before you ever enable the firewall on a remote server. Now that SSH and Apache are both allowed, it's safe to turn the firewall on. I'll run sudo ufw enable. It's warning me that this may disrupt existing SSH connections and asking if I want to proceed. Since I've already allowed OpenSSH, I know that it is safe, so I'll type Y and click enter. Let's confirm that everything looks right. I'll run sudo ufw status verbose. Here's the full rule table. You can see that the firewall is active. The default policies deny incoming and allow outgoing, and both OpenSSH and Apache show as allowed. Now let's replace Apache's default page with something of my own. First, I'll navigate to Apache web root. I'll run cd space /var /www/html. I'll run ls-l to see what's in here. There's the default index.html file that Apache installed automatically. This is the file it serves to anyone who visits my server's IP address, and it's the one I'm about to overwrite. I'll open it for editing with sudo nano index.html. I'll open it for editing with sudo nano index.html. I need sudo here because this file is owned by root and my regular user account doesn't have permission to overwrite it directly. Now I need to clear out the default content before I write my own. At the very top of the file, I'll mark the start of my selection with Ctrl+6. I'll jump to the very bottom with Alt+/ and I'll cut it with Ctrl+key. Now I'm writing my own simple HTML page. It will include a heading with my name and a short paragraph describing this assignment. To save it, I'm pressing Ctrl plus O to write out the file and pressing Enter to confirm the file name, and then Ctrl X to exit Nano. Let's double check the file's permissions to make sure Apache can actually read it. I'll run ls-lh index.html, and the permissions here read -rw -r-r-. That means I, as the owner, can read and write the file, and everyone else, including the Apache process itself, has read access. That read permission for others is exactly what lets Apache serve this file to visitors. Now let's test this from the client side. I'll copy my IP address and I'll head over to my browser. I'll type http:// and the IP address I found earlier into the address bar, and I'll press enter. And there's my custom page from a completely separate machine over the network. You can see the heading with my name and the paragraph I wrote. This confirms it's my custom content, not the Apache default page, and that it's reachable over the network, not just locally on the server. It's not secure, but the requirements did not include that. I'm back on my SSH session and I'll check that Apache actually logged that request. I'll run tail-n5/var/apache2/access.log. Here's the log entry from my browser request. You can see my host machine's IP address, the request itself, get/http 1.1, and a 200 status code. That's Apache's own record confirming my browser's request reached the server and was served successfully, which wraps up part 2. That completes the full project. I've installed Ubuntu Server 22.04 LTS in VirtualBox, configured it and connected over SSH, installed Apache, secured the server with a UFW firewall while making sure SSH stayed allowed, deployed a custom HTML page, and confirmed it's reachable from my host machine's browser with a matching entry in Apache's access log. Thank you guys for watching this video, and I'll see you in the next one.